Hey guys, welcome back to another new video of Pranav's lecture. So in this video, we will learn about a new topic, that is Huffman's coding. So what is Huffman's coding? So Huffman coding is a greedy approach based on the losses of data comparison algorithm. Okay, it is used in variable length encoding to compress the data. The main idea in Huffman coding is to assign each character with variable length code. Okay, the length of each character is decided on the basis of their occurrence frequency. Clear? Means it is a basically greedy technique. So, before going to the topic Hoffman's coding, in your mind a question arises: why we needed data comparison? Okay, so data comparison is needed because, see here, let's take a message is given. Okay, let's a triple B double C double D and triple E. Okay, this is a message given. Here we talk about the single letters. Here A, B, C, D, E. Okay, so if we talk about A, what is the ASCII value of A? What is the ASCII value of A? You know that 97. Clear? The ASCII value of A is 97. So if I want to represent 97, then how many bits will be needed? 2 to the power 7, 128, 2 to the power 6, 64. So this is more than 64. So we cannot represent it 97 in 6 bit. So it will take 7 bit. 7 bit. So if I want to represent A, I needed 7 bit. Similarly, B, C, D, then the total how many characters are there in the message? How many characters are there? 3, 3, 6, 7, 8, 9, 10, 11, 12, 13. The total 13 characters are there in the given message. So the total how many characters are there? So 13 into 7 bit equal to 91. Okay, 91 bits. So I will need 91 bits to encode the message in a normal way. But Hoffman is a greedy approach. We will reduce the normal of bits based on their frequency. So here, first of all, if we talk about frequency in this type question, you have to count what is the frequency. If a message is given, then you have simply count the frequency of A is 3, B frequency is 3, C frequency is 2, D frequency is 2, E frequency is 3. Most of the time, the frequency is already given in the question. Okay, so we do not have to count like A is repeated in 3 times, B is repeated in 2 times, like that. But if not given, then you count simply in the message. So here we use a mean heap data structure. So what is the minimum element here? So we find out the minimum element, then we find out the second minimum element, then we simply add that. Okay, so by throwing an example, I can explain you how the Huffman's coding is working. And one thing remember, when we represent Huffman's coding, in the left side we always use smaller element, and the right side we use the larger element. So in this way, follow this method and this nomenclature, always your answer will be correct. So now see a question, how the question is asking. So this is our question, means here frequency are given in that question, means F frequency is 5, E is 9, C is 12, B is 13, D is 16, A is 45. These are our question. We have to draw the Huffman's encoding tree. Okay, so step number 1. Okay, so step 1. So step 1, what we told, we use here mean heap data structure. Means first we have to find out the minimum frequency. So here what is minimum? What is minimum? So first F5, it is the minimum, and the second minimum, this is. So simply we add F5 and E9. So what is the result? 5 plus 9, 14. So simply I write 14. Then here left side F5, in the right side E9. Then write the remaining parts: C12, B13, D16, A45. C12, B13, D16, A45. Clear? Yes or no? Okay. So the second step, step number 2. In step number 2, we have to rearrange these things because it is not in increasing order. So we have to arrange these things in an increasing order, or you can say that ascending order. So here first C12 is come, then B13, then 14 F5, here 9 E9, then D16, then F45. Clear? Okay. So then step number 3. In step number 3, again we find out the the smallest frequency and the second smallest frequency. So here the small is this. Okay. So minimum is this. So then the second minimum is B13. So we simply add these two. Okay. Clear? So what is the result will be? 25. Here C12 and here B13. Clear? Then 14 will come in the same position. F5, E9, then D16, then A45. Clear or not? Okay. So now step number 4. Again rearrange in increasing order. So first here 14 come, F5, E9, then D16, then 25, C12, B13, then A45. Clear? Yes or no? Then again we take the least two elements, means least two frequency. First least element is what? Here 14, then here is the least second 16. So simply we add these two. So in the step number 5, we simply draw this 14 plus 16. So what will be the result? 30. And the left side 14, then F5, here E9, and 30, right side D16. Then here comes 25, C12, B13, then A45. Clear? Okay. So again step number 6, again rearranging this 25, C12, B13, 30, 14, F5, E9, D16, and here F45. Now the first minimum is 25, the second minimum is 30. So we have to add these two. Clear? Then step number 7. So what will be the result of 25 plus 30? 55. Then in the left part, 25 C12 B13, in the right side 30 14 E9 F5 D16, and here F45. Now we step number 8. So here I directly write down this, because when we rearranging again the step number 8, this is coming to the this position and it will be the 8th position. Then we have to add these two. So simply I write 100, here A45 will come, then in the right side 55 25, then C12, then B13, then 30, then 14, then F5, then E9, then D16. If you don't understand, I can simply write down this step because you are confused. Step number 8. This is step number 9. Okay, so first what we write? F45, then here 55, 25, then these things 30, 14, this, you have to fill up this. So then we add, this is in the left part. Clear? So this is our, so this is what? This is our Huffman coding tree. What? This is our Huffman's coding tree. Clear? So this is our Huffman's coding tree. So now what we do? The question is given, that the question is asking the total number of bits you can find out and the average number of bits per character you can find out. So how to find out? So first we have to place 0 and 1 like that. I am doing. Simply we place 0 1 0 1 0 1 0 1 0 1, like that you can place 0 and 1. So now an encoding is there, means these are, we can write the both from root node to that node, like that. Now now encoding means per character we can encode the data, means like f. The encoding is what? For f character, means f is here present. So what I do, from root node to destination node, we have to find out the path. So here 10 to 50, 50 to 30, 30 to 14, then we reach at the destination point F5. So what will be the result? Simply write down 1 1 0 0 1 1 0 0, like that. E equal to 1 1 0 1, C 1 0 0, B 101, D 111, and A is 0, because A is this 0. Okay, so this is our encoding. Now we have to find out the total number of bits. What? Total number of bits required. So total number of bits, the formula is number of bits into frequency count. Number of bits into frequency count. For F, the number of bits is 1 2 3 4. So 4 into frequency count, means here the frequency count is 5. So simply I write 4 into 5, 20 bits. Similarly for E, 4 into 9, 36 bits. For C, 3 into 12, 36 bits. For B, 3 into 13, 39 bits. For D, 3 into 16, 48 bits. For A, 1 into 45, that is 45 bits. Then the total bits are, we simply add these, and 224 bits. Clear? And the next formula is average number of bits per character. Average number of bits per character equal to total number of bits divided by total number of characters with including frequency count. So here average means 224 by 100 equal to 2.24 bits. I hope this video is very much interesting and informative and also valuable for you. So please like, share and comment on our video. Thank you. Jai Jagannath.